Once again, I'm recording your voices, but not your faces anymore. And I'm recording this slideshow starting right now. So, again, in the sake of transparency, I want to be very clear about what I'm about to teach you right now. This is coming from our massage therapy textbook, which is a great textbook. But I want you to remember this. When I go to massage places with massage therapists, and you see them sitting in the lounge, like between clients, you never see one of these books out, ever. But you do see a trail guide book out almost every place you go. That does not mean, please don't misunderstand me, that does not mean that this is a bunch of junk and I don't need to ever hear about it, Tapscott, and don't worry about it. But it does mean that this is full of stuff that in some ways you will not use every day. What you will use every day is bones and muscles, bones and muscles, bones and muscles, which is trail guide. So I keep repeating this because I'm going to go over stuff today that's really important that you've heard about. We're going to learn about cells and terminology, and you need to know that cells exist. I mean, you do, or you won't understand other things. But do you need to be a cell expert? No, 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 no. All right? So I just want to frame the conversation. I want to explain where we're going. Please don't tune out when we're working on this book. It's important that you've heard this stuff. But at the end of the year, if you could learn everything in the trail guide and remember very little from this, but recognize it when I talk to you about it, you'd be an amazing massage therapist. So today, we're going to kind of learn about some real basic concepts of the human body because we're going to learn about the building blocks of the human body, and you have to understand the building blocks to kind of understand where the muscles and the bones and all that stuff came from. We're also going to learn about the building blocks of language itself, right? This whole time we've been using terms like superior and inferior and lateral and medial, and those are Latin terms. And once you know those, I think you've already seen that you can start naming an awful lot of stuff without memorizing everything. And so in this chapter of the book, they're going to be talking about some of that kind of stuff, and I want to go over it. I will also be skipping over some of the stuff in this chapter of the book because I think it's a little bit too detailed for where we need to head. Yeah? Please feel free, once again, to ask questions, all that good stuff. Okay. So we're going to define anatomy and physiology, what those words mean. Homeostasis. We're going to discuss a little bit about medical terminology, which is really the Latin stuff, the Latin roots, suffixes, and prefixes, and I'll explain that. And then we're going to discuss cells and tissues and membranes, but a simpler way of thinking about that is we're going to discuss the building blocks of life, how you're made, just the basics. Okay. So you are all in anatomy class right now, right? And anatomy is really the study of structures and parts of the body in relationship to one another, just where they're located, really. So anatomy in some ways is knowing that the heart is right here. It's not so much about knowing what it does. Physiology is more about knowing what the heart does. Anatomy is about knowing where it's located and what it's called. So anatomy is knowing that this is my heart. Physiology is understanding that it pumps blood. Pathology is the study of anything that can go wrong with that. The study of disease itself, what can go wrong with my heart. I'm going to give you some more examples of that. I just want to kind of give you an overview. Okay. So, right here, and somebody took the time to underline some of this stuff for some reason. Can't imagine why, but maybe because it's important. Anatomy is the study of structures of the body and their positional relationships. So I just said that in very simple terms. Positional relationships just mean where they are in relationship to one another. So this is my heart here, and it's between my lungs. Now that doesn't tell you very much. If you don't know what a heart is or lungs are, it doesn't tell you very much, but that's anatomy. That's the structure here. When we learn about the clavicle, and it's here, that's just anatomy. It's just a clavicle, it's here. Here's the sternum, here's the clavicle, here's the acromion process. That's all anatomy. Think of anatomy as just naming stuff and knowing where it's at. It's kind of like geography, right? I know where Tucson is, and I know where Flagstaff is, and I can't tell you anything about them, but I know how to find them. That's anatomy. Physiology is about the function. Physiology is about the function of those parts. I know the economy of Flagstaff. I know where all the best restaurants are. I know how the citizens work there, right? It's about the function. Anatomy is I know my heart's here. Physiology is I know what my heart does. It is a 4-chambered pump that pumps blood through blood vessels in my body, out through veins, and out through arteries, out through arteries to the rest of my body, and back via veins back into my heart. And it makes it past the lungs there too to pick up some oxygen too. But I know what my heart does, the function of it, the purpose of it. So anatomy is knowing that you have an engine underneath your hood. Physiology is knowing that it burns gasoline and makes the car go. Yeah? Homeostasis is the tendency of your body to remain in balance. Your body operates actually in a very narrow range, especially the core of your body. I said this before, actually early on in one of our lectures for some reason, I don't even remember now, but my arms can get extremely hot or extremely cold. They can drop by 30 degrees and I will live. In fact, my arm will probably be okay if you don't leave it that way that long. But my core temperature has to remain very steady. It has to remain within a few degrees, actually, for me to live. And so my body is constantly seeking homeostasis, which is balance. It's climate controlled, right? But it's not just climate controlled, by the way, it's chemical balance and everything. The reason that you pee and poop and all that kind of stuff is not just to get rid of byproducts, but it's to stay in balance. When your body says, hey, there's too much salt in here, it makes sure you pee it out. When there's too much potassium, it makes sure you pee it out. When you have too little, it doesn't pee it out. It tries to keep you in balance. If you think about it, you're a big wet sack of chemicals and water. Yay. A beautiful, amazing, miraculous sack of chemicals and water, but you are a big sack of chemicals and water with an opening at both ends. Put stuff in and stuff comes out, and your body has to figure out what to do with all that. So homeostasis is the tendency of the body to try to stay in a stable state. We care about this too because your body tries to do this homeostasis with your structure as well, and with my posture. So if a muscle tenses up that's pulling my shoulders back, my body doesn't want me walking around like this all day long, so it tenses up muscles in front to pull it back like this. What's important about that from a massage therapist point of view is the muscles in the front and back now might both be tight because they're arguing with each other to try to keep me in homeostasis. So homeostasis also applies to posture. Your body is trying to correct the stuff that you do to it and trying to stay in good posture. Cool? So anatomy is the parts and where they are. Physiology is what they do. Homeostasis is trying to keep all that stuff working in balance. In your book, in chapter 18, there are 2 pages that have prefixes, roots, and suffixes. Don't even worry about what a prefix, a root, and a suffix is in and of themselves. A prefix just means it comes before, a root is the middle, and a suffix afterwards. Don't worry about these definitions. The fact is that knowing some basic Latin helps you with medical terminology because most medical terminology is in Latin. Yeah? So you've got some common words that we use, right? Does anybody know what a word is that means up? Anybody?
Elevation.
Elevation. But what'd you say, Miss Giannis?
Superior.
Superior. And superior comes, elevation was correct, by the way, but superior is correct too. Superior has a Latin root in it, which is supra. Anything with supra in it means up. And so what we're going to do is take a little quiz to force you to look at the 2 pages in your book with those roots and stuff and just match them up. It's just a matching quiz, right? And all I'm doing is making sure that you read those 2 pages because there's lots of stuff like superior, inferior, medial, lateral, infra, sub, hypo, hyper, all this stuff that we use all the time. There's only about 25 words that we use all the time for the rest of this course, and you will use for the rest of your life that will make your life a lot easier. Yeah? So we're actually going to take a break right now to take that because it will not take you a long time. And I'm going to have everybody take this test that I'm going to release right now. But it's based on these 2 pages in your book, and those page numbers are, and I'm expecting you to look at your book. I want you to read it. That's why I did this. Those page numbers are page 342 and 343 of your Massage Therapy Principles and Practices Susan Salvo book, 6th edition. And let me open up this test right now. So, there we go. Okay, moving on from medical terminology. We want you to understand how your body is made, just in real basic terms. And they call this levels of organization, and every biology class goes through this, and I think it's kind of confusing, and it's a very simple concept. If I was building a building, I would start with bricks. By the way, I realize you'd have a foundation and permits and all that kind of stuff. Just stick with a very simple analogy here with me. If I had a building, I would start with bricks. Let's try to get a darker color here. Right? A brick would be my most basic level of organization. If I put a whole bunch of these bricks together, I might have a wall. Still don't have a building, right? I put a couple of walls together. I've got a room. Put a whole bunch of rooms together, and maybe I've got a building. That's all levels of organization means. It means we start with these tiny things and we stack them and we put them together, and then we can build something that's much more complex, and the thing they're leading to is you. So let me forget about the building analogy. Let's go to the real analogy, which is you. Okay? The universe, as far as we know it, starts with atoms. Actually, there's a lot of evidence to suggest it starts way before that, but let's keep it simple here. We start with atoms. Like carbon, oxygen, hydrogen, atoms. Okay? Very basic building blocks. Those are elements. In this slide where it says elements, that is truly what an element is. It's a single unit, an atom. Like carbon, hydrogen. Have you ever seen the periodic table? Those are all elements. When we put elements together, like hydrogen and 2 oxygens, they actually have an attraction, and they bond together. Make up everything else. Oh, that was good. Because they bond together and they make a chemical. They make something that's a molecule. They make something that's much more complex, right? In this case, hydrogen and oxygen that are both gases. They're in the air right now. I just breathed in a whole bunch of hydrogen, oxygen, and nitrogen. There's actually a lot of nitrogen in the air. And I just breathed out a whole lot of all 3 of those things and CO2. But anyway, if you put these 2 gases together, hydrogen and oxygen, in this format, you get a really lovely substance. What do you get when you put hydrogen with 2 oxygens? Maybe it'll help you if I say it this way. Water. Thank you. You get water. So you get molecules that come together, which are chemicals essentially in this thing. Now, if you take another step further and you put chemicals together, you can create things called organelles. What the heck are organelles? Organelles are quite literally the organs of a cell. You have organs, cells have organs. They have things inside them that do stuff so they can stay alive. You have things inside you that do stuff so you can stay alive. They actually have very similar things inside them, and we'll get to that in just a second, but we have to kind of build up from here. If you take a whole bunch of cells together, you get tissues. Now that sounds kind of complicated, but if you think about it, it's really simple. If this is a skin cell, and I put it with another 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 skin cell, eventually you have skin. That's a tissue. That's all they're saying. Just like if I have a muscle cell, and I put it with another muscle cell, another muscle cell, and another muscle cell, after a while I've got a steak. Or a pectoralis major. Or a biceps brachii. So when they say that cells make tissues, that's 100% true, but it just means that you put a whole bunch, put a whole bunch of people together, all of a sudden you've got a crowd. A group of people. Tissues are groups of cells of the same kind. Now you put tissues together, often different types of tissues together, and you can make organs. Like your heart is made up of a lot of muscle tissue, right? And you've got an organ. If then we take a whole bunch of organs together, like my heart and my lungs and my arteries and my capillaries and my veins, we now have a system, the cardiovascular system. And if I take a whole bunch of systems together, the lymphatic system, the skeletal system, the muscular system, the cardiovascular system, if I put all those, the nervous system, don't forget that one, if I put all those together, I have an organism. I am an organism. You are an organism. So they're really just talking about how stuff is put together. Levels of organization. We start out with very simple stuff, although atoms aren't that simple. We put atoms together, we get molecules or chemicals. Those chemicals can make little organs for a cell. Eventually you've got cells. You put a whole bunch of like cells together, you've got tissue. You take tissue, you can make organs for our body. Different organs working together make systems in our body. A whole bunch of systems together make us. This is just a way of thinking about how you're put together so we can talk about your body. That's all. Are you following me so far, do you think? We're really just talking about bricks, making walls, making rooms, and it really is that simple. We're using different words and things like that, but same thing. Cool? All right. Okay. So we're telling you all that because we want to talk about these levels a little bit. It's a great slide of levels. The atoms making the molecules, making the proteins, making a heart muscle, making heart tissue, making a heart, being part of a system, a whole bunch of systems together, being an organism. Okay. Let's talk about cells, and this is actually very important. A cell is considered to be the most basic living unit. Now, it depends on how you define life, but as we define it in medical terminology, a cell is essentially a self-sustaining unit. That's a little bit deceptive because they can't live without you. But the fact is, it is something that eats and excretes. It's not quite true, but it eats and it poops and it pees and it reproduces. So it actually shows basically all the characteristics that you do. And I actually want you to think about cells just like you think about your own body. You're made up of them, by the way. There's nothing on your body that's not a cell. Nothing, except your clothing. But I meant there's nothing that's your actual body that's not a cell. And they're very much like you. And so cellular health is your health. If your cells are healthy, you're healthy. And cells are very similar to you, and it's a really good way to understand cells. All right? First off, cells, 60 to, I say 80, but anyway, 60 to 80% water. If cells are 60 to 80% water, you are 60 to 80% water. You're actually more, and we'll get to that in a minute, because you've got water between your cells. But you are mainly water. So how important is water to life? It's extremely important. If these cells dehydrate, they die. If you dehydrate, you die. You are mostly water. The rest of cells are actually made up of little elements. Don't stress about this. I don't need you to memorize this. But of carbon and hydrogen and nitrogen. And then you got some trace elements in there like iron and things like that that you use to build the little stuff inside your body. Cells, just like you, have to eat. And in order to eat, stuff has to get inside the cell. It actually has to open up its skin and let stuff through. You do the same thing when you eat. You open up your skin and let stuff through. You do it like this. Right? I can close this open if I want to. I rarely do, but I can close it if I want to. And I can let food in there. And then cells have to get rid of stuff too. They have to open up their skin again. There's literally your skin. It's the cell membrane. It's their skin, just like your skin. And then let stuff out. You do that by going to the bathroom. You also do it by sweating. So it's not the only, you don't just go to the bathroom. You also sweat and release a lot of stuff too. Yeah? This, by the way, will relate to massage in a second. Directly to massage. Because massage can actually aid in cell health. That's why we're spending time teaching you about cells. I don't care that you become cell experts. There's no need. But I want you to understand the concept of a cell, that it's this little baby living creature that makes up your whole body. There's millions and millions and millions of them. They're mostly water, and they have to have stuff coming in and out of them to be healthy. Yeah? So, let's talk about the parts of the cell. I'm going to try to draw this bigger. Who can tell me the largest organ of the body? The largest organ of the body. Yes? Skin. Absolutely. You have skin covering your entire body, right? And your skin, by the way, is the gatekeeper of your body. It keeps stuff from getting in. The reason you can rub other people and not die of infection is because your skin is actually extremely good at stopping infection. Right? In fact, most people, when they get infection, they get it because it comes in an opening of their body, not through their skin. Your skin is actually incredibly good at being the gatekeeper of the body. Well, the gatekeeper of the cell is called the cell membrane. And it really is just a fancy word for cell skin. It's the cell membrane. Yeah? Cell membrane. Sometimes your cell membrane, by the way, has little stuff coming off of it. In different areas of your body, called microvilli, cilia, flagella. These are little hair-like projections, finger-like projections on the cell that actually help the cell get around or help it move stuff by it. Because they have to kind of swim around a little bit. They don't just sit there. So some cells have these finger-like projections off them. You don't, again, don't have to be an expert at this. I just want you to understand the concept. Cool? Inside this cell, boom, is cytoplasm. Some people call it protoplasm. Cytoplasm, protoplasm. Basically, it's like the blood and plasma of your body. It's a soup. But inside your body is essentially a soup. Really is. And what's this soup full of? All the nutrients that the organelles need to eat and stuff like that. And that might sound kind of weird, but you're doing the same thing right now. The stuff inside your body has to get fed from something. It's getting fed from all the blood being pumped around your body. But it's not like it's a clean, well, it's clean. It's not like it's a dry area in there and there's tubes coming there and feeding your organs. You are wet inside. And your organs are grabbing stuff from the wetness. You too are a soup inside with nutrients. By the way,
What is that called? I'm sorry.
no, that's okay. That's cytoplasm. Cytoplasm or protoplasm. And here's the part I don't like, that I think is a bit much, but I think they're going to test you on a little bit of this. That, by the way, cytoplasm just carries nutrients that support the organs inside the cell. But then they start to name the cytoplasm different stuff. Like endoplasm is the cytoplasm inside the organelles. So if you have an organ in here, there's cytoplasm in it. They call it endoplasm. Don't stress about that stuff, please, at all. The cell has a cell membrane, and it's full of cytoplasm, which is a big soup. It's a big soup. And it's literally like soup. It's good for you. It's got stuff that the cell needs. Then inside the cell, it's got different types of organelles. And honestly, organelles are cell organs. Right? Cell doesn't have a heart, but it might as well. Cell doesn't have lungs, but it might as well. It's got organs that does stuff for the cell. And we're going to talk about those organs that do stuff for the cell. You have a skeleton. The skull has a cytoskeleton. Now, it's not like bones like you would think. It's actually kind of like filaments and stuff in here. They kind of give the cell some shape so it doesn't collapse. Just like your skeleton keeps you from collapsing, the cytoskeleton does the same thing. And it's a whole bunch of little filaments, microfilaments, like little wires that help kind of give the cell some structure. Because the cell doesn't want to collapse. Cool? And they give it internal structure. That cytoskeleton is one organelle inside the cell. There are other ones. There is something called endoplasmic reticulum. Endoplasmic reticulum helps to move stuff around in the cell. If you're over here and you need nutrients from over here, the endoplasmic reticulum helps get those nutrients over there. Because in this microscopic world, that's a long way to go. Endoplasmic reticulum helps move stuff around. That's all you really need to know at this point. I mean, by the way, it does help produce proteins and carbohydrates and all sorts of stuff, but it helps move them around while it's producing them. You've got something called the Golgi body, and I wrote UPS next to it here because that's what the Golgi body does. Golgi body transports stuff out of the cell. And by the way, that's not just waste. Your cells make up really cool stuff. Like when they decide you need something, they help make it, and the UPS, the Golgi body, sends it out into your body so that other cells can get it, so that you can get it. Your cells are working all the time making stuff for you. And then the Golgi body packages that stuff up and sends it on out and gets it back in the bloodstream so that the rest of your body can have it. This next organelle is probably the most important. It's called the mitochondria. And everybody says it's the powerhouse of the cell, and I do too. The mitochondria is what produces usable energy in your cell. Yeah? So, the mitochondria produces something called ATP, adenosine triphosphate. We're not even going to worry about that, but it's a very powerful chemical, by the way, that when it breaks apart releases a lot of energy. And so your mitochondria produces that, and your cell uses that to do work. What kind of work? Well, every time you open up this cell wall and pump stuff in and out of here, that takes energy. Stuff doesn't just happen on its own. Sometimes it does, but in general it takes energy. And your cell mitochondria produces the ATP for your cell to do work. So that's why it's called the powerhouse of the cell. And you just kind of want to remember mitochondria, powerhouse of the cell. Power to the mitochondria. This is a side note, and I don't think your book goes into this, and I think it's really a shame, because I think it's absolutely fascinating. The mitochondria has its own DNA, and you actually get it from your mother. So you have the exact mitochondrial DNA as your mom did, and her mom did, and her mom's mom did, and her mom's mom did, whereas the rest of the DNA in your body is a mixture of your two parents. Like you're basically all half your mommy and daddy, not your mitochondria. Your mitochondrial DNA comes from your mother. In fact, they did a really fascinating study where they looked at people's mitochondrial DNA, and they said, okay, well, this person got it from their mother, and this person got it from their mother, and this person got it from their mother. And they actually traced back every single person's mitochondrial DNA all the way back to essentially one person in Africa. Kind of shows that all people came genetically from one person at one point. We were definitely all one race at one point. Mitochondrial DNA is proof of that. But the fascinating thing is that it's the DNA that you don't split. You get it from your mom every time. Very, very cool stuff. Powerhouse of the cell. I could go on about it, but we've got a lot of other stuff to cover. It's very interesting how we think it got in there and all that kind of stuff. Anyway, mitochondria is powerhouse of the cell. Lysosomes. I call lysosomes the police of the cell. They find stuff that they don't like in here, and it might be bad stuff, but it also just might be stuff not being used, and they break it down. They break it up so the cell can use it again or get rid of it. They're the police of the cell. Don't worry about centrioles. The nucleus. You have a brain. Your cell has a brain.
I'm sorry, what is the police of cells?
Lysosomes.
Thank you.
Yeah, and by the way, your question is perfectly fine, but can you guys see my PowerPoint? You can't? Good, okay. It's okay you asked the question. I just want to make sure that you can also see the PowerPoint. Yeah, you're welcome to verify stuff, don't worry. Anyway, the nucleus is the control center of your cell, and it's essentially the brain. It's essentially the brain. That's a huge oversimplification, but it is the place that reads the RNA and DNA. Well, the RNA is a reader and DNA, it doesn't matter. It reads the blueprints in your cells so it knows how to make more cells. It also knows how to make proteins for your body and all sorts of stuff. It's the place that reads the instructions on what to do. Remember when we talked about viruses last week? A little bit?
Yeah.
Viruses actually do this sneaky thing just to make a point about the nucleus. Viruses have their own DNA. They come along and stick it into the brain of a cell, and then that cell starts making copies of the virus. It doesn't know. Right?
Mm-hmm.
So it's like if Miss Waite has an instruction manual and she's building a table, and then one night while she's sleeping, I replace the instruction manual with one to build a motorcycle, and then I come by and say, thanks for building me a motorcycle, and she's like, darn it! Didn't even realize it. I just followed the instructions. The only problem is then she's going to build another one and another one and another one and another one and another one, because that's what cells do. They repeat. So anyway, the nucleus is what reads the blueprints inside your body. And that's how it knows what to do to make other proteins for your body, make other cells for your body, all that kind of good stuff. And a virus comes along and hijacks that and puts its own blueprint in there. Viruses actually aren't alive. They actually stick their blueprint in something that is living and let that program run. Cool, cool, cool. All right. Beautiful picture of a cell here. Miss Petrie, will you cut your mic?
Oh, sorry.
That's okay. That's okay. Okay, so really quickly, remember some of the most important stuff, I'm sorry to keep using this analogy, but it's really true. Some of the most important stuff we do is eat and poop and pee. And I say that because if you stop doing any of those for too long a period of time, you die. The same thing is true with your cell. It's got to get stuff in and it's got to get stuff out. It has to. That's what living creatures do. And so it has ways of moving stuff passively and it has ways of moving stuff actively. Passively means it doesn't usually require energy and it just kind of happens. And I'll explain how that happens in a second. And then there are active ways where it can move stuff through the cell using ATP to actually fuel that move, right? So passive is kind of like when you've got your car up to the top of a hill. It will passively roll down that hill. Active is when you want to get the car up the hill, you've got to use gas to get up there, right? So you can use both processes depending on what you need to do. But again, whether it's passive or active, these are processes to get stuff in and out of the cell. And these are just terms that your book would like you to know, that I would like you to have heard of. And again, the reason I want you to hear of this stuff is later if we discuss a concept in massage therapy that has to do with cellular health, we want you to at least understand that, like, oh yeah, cells have a membrane around them. They're kind of like a skin, and they've got a nucleus that kind of reads the instructions and makes more cells. And that cytoplasm is mostly water in the inside, but it's really important. It's got to get new water in with nutrients in it. It's got to get the bad stuff out. Those basic concepts really help you understand, like, why massage is important later. Or if you're reading a medical journal about a new type of massage, it helps you understand, like, what they're talking about. You need some base knowledge, and that's all we're trying to do today. Build that base knowledge. So, diffusion is the movement of molecules from an area of high concentration to low concentration. This might sound confusing, but you guys do it all the time in a way. If you have a drink and you pour sugar into it, or you have a drink, and I don't know why you put salt in it, but if you pour something into it, that sugar is in high concentration. What does it do? It doesn't just sit in one corner of the drink. I mean, it does for a while. But eventually it spreads out and the concentration is even. Every sip has the same amount of sugar in it. That is moving from a high concentration to a low concentration until it's equal. Things will always do that. If you pour a glass of hot water and cold water together, eventually you have warm water. They just equal out. Things want to move to that way. They do. And they do that without added energy. They try to equalize. The hot stuff goes over here and the cold stuff goes over there and they equalize. The sugar over here says, oh my gosh, there's space over here. There's no sugar over here. And it tries to fit in that space until it's all equal, until all the space is equaled out. That's diffusion. That's all it is. High concentration to a low concentration until it equals out. Osmosis is doing the same thing but with water. And the way your book puts it is very confusing. But what's happening is the water is moving until the concentrations are equal. So if the sugar's over here, the water would be kind of moving to the sugar until it's all even. But it's still the same concept. It's water movement to equalize things out. Just think osmosis, water movement to equalize things out. And filtration is using a membrane to do that. And Miss Felix Osuna did this morning. Miss Felix Osuna knew we were going to have this lecture today, and she used filtration when she used a coffee filter to make her coffee.
Yes.
The coffee filter was a membrane that filtered out certain stuff and let other stuff through. That's all filtration is. And it makes a delicious cup of coffee. But your cell membrane can do the same thing. Cell membrane can do the same thing. Cool? So diffusion is moving stuff from high concentration to low concentration until it kind of equals out. Osmosis is really the same thing with water. And filtration is using a filter to allow certain things to come through and not others. And those are all passive. Oh, wow, they even used my example. I honestly didn't know that. Okay, we're moving on, though. When you have active filtering, let's suppose it's not from high concentration to low, and you've got to push something up the hill, the car up the hill. I've got all this sugar over here, and I want to push even the last bits of sugar out of here up to there. That takes a lot of energy, and that would be an active cellular process, and that would require ATP. That's called active transport. I'm having to push stuff out of the cell that doesn't want to go out of the cell. There's pressure working against it. I don't have gravity working in my favor. I don't have concentration working in my favor. I'm having to drive stuff out of the cell. You're working against stuff. So one of the big ways you do this is transport by pumps. Your cell actually has little pumping mechanisms. They have carrier molecules, and it uses ATP, it uses energy to use those molecules to pump stuff out of the cell. And those carrier molecules are right in the membrane, and they're like little guys in the gate, and they help kind of shove stuff out of there. By the way, if you were a biology teacher right now, you'd be turning over in your grave. But the point is, you'd essentially shove it out of the cell, and I'm using ATP to do that, and I have to shove it out of the cell because it's high concentration up there, and it really wants to come this way, and I'm like, no! I've got to get this stuff out of there. I need to use force to do it. Force to do it. Vesicles is kind of the same thing. Just remember, transport pumps. They pump stuff out of the cell, and they use energy to do that. Questions so far? I'm sorry, what I'm trying to do is actually cut out the fat from this discussion, because I want your head full of things like bones and muscles, and I want you to understand cells, but I also don't want you to memorize like the cytoplasm inside this one organ on a Tuesday is called this thing. Like it's not helpful at all. I do want you to understand a cell has skin around it called a cell membrane. It's got a brain called a nucleus that reads the instructions. It's got a mitochondrial that makes, the mitochondria that makes ATP that fuels stuff. It's got to get stuff in and out of it. Sometimes it can do that passively, through like osmosis using water. And sometimes it has to do it actively and use that ATP and really pump it out of the cell. Use a transport pump to get it out of there. Cool? Kind of, sort of? Okay. I see one person nodding. That's good. Thank you, Miss Wade. Oh, 2 people. All right, good. Oh, that's true, huh? Side note here. Cells can also get stuff into the cell by kind of enveloping themselves around it. And these are called phagocytes. They're little Pac-Man cells. And what they do is this thing called phagocytosis. It's important because later when we study the immune system, we're going to talk about this. Phagocytosis is literally the cell kind of, I wish I had something to show you with this. This is not a good example. But if this is the cell and it finds something that, I don't have anything small. If it finds my car key, and it's like this car key should not be here, it will actually envelop itself around it, and then it will form the new cell wall there and bring the car key in that way. And it actually eats it, and then it breaks down the car key on the inside. That's called phagocytosis. They're phagocytes. They're cells that eat stuff. That's how they get it in there. They're very helpful when you have bad stuff in your body because they're like, this person's bad, I'm going to hug him to death. Yeah. Phagocytosis. That's all I want you to know about that. Because later we're going to study that in your immune system. Okay. So far, we've been talking about the building blocks of life, right? And we said the first building block was like the little elements. And then the elements come together and make little molecules. And the molecules come together and make organelles. And those organelles work together to make a cell. And then we said a cell is the most basic living unit of life. And we say that because it seems to be able to essentially eat things, process them, get rid of them, make more of itself, make little cell babies. And so we call that a living thing. Things that can reproduce we tend to think of as living things. And then we got to a cell. And if we take a whole bunch of cells, like I said, if I take a whole bunch of skin cells and put them together, all of a sudden I have a tissue called skin. Yeah. There are 4 basic types of tissues. They have all these subcategories, by the way. There are 4 basic types of tissues. Muscle is one of them. Muscle only does one thing. What is that one thing? Miss Stanley, what's the one thing that muscle does? It says it on the slide, by the way, too.
It says it only contracts.
It only contracts, yeah. So anyway, it's a type of tissue, and it's a type of tissue that it's one of the 4 main types of tissues, and it's a type of tissue that we're going to be studying for 8 months, right? We're very, very interested in muscle. It's one of the 4 main types of tissue. Nervous tissue is the tissue, it's not nervous, it's the tissue that connects your brain to the rest of your body, to your muscles, to your sensors, all that stuff. That's nervous tissue. It's what communicates with your body and back to your brain, nervous tissue. Connective tissue, you know how fascinated I am with fascia and all that kind of stuff, right? Connective tissue is the most abundant tissue there is. That's why I tell you fascia is everywhere. There are many types of connective tissue, but connective tissue is the structures and the glue that holds your body together. We're going to discuss different types of connective tissue here in a minute, but it is the most abundant tissue in your body. So it's why I make such a big deal about fascia, because it's not all about muscle. It's also about the connective tissue that binds the muscle together, the connective tissue that binds the bone together. Your blood is connective tissue, believe it or not. We'll get to that. And then there is a 4th main tissue called epithelial tissue, and that lines the cavities of your body. And so what they mean by that is it lines the insides of my body, the insides of my digestive tract, the insides of my rib cage. It lines the inside cavities of my body. Epithelial tissue. It's there to protect things and help things slide over one another and all that kind of good stuff. So 4 types of tissue. Now there are subtypes, by the way. You know, it couldn't be this easy, right? There's 3 types of muscle, for example, but there are 4 main types. Epithelial lines the insides of my body. Connective runs through everything, like the force. Muscle only contracts, right? There's several types of muscle, but they all still only contract. And nervous, which is all the communication lines and your brain itself, by the way, that run throughout your body. 4 types of tissue. Boom, boom, boom. We're not going to worry about that. Okay. So, regardless of what type of tissue it is, it's made up of a whole bunch of cells, right? Yeah. Cool? Now, I said those cells have to eat, and I said they have to go to the bathroom. Do they go to Jack in the Box when they want to eat? No. No, and they can't go walking around that much. I know they've got little microvilli and stuff like that, but they pretty much stay in the same spot most of the time. They have to eat from the fluid that's around them, that's between them. Interstitial fluid, the fluid between the cells. So your book puts it very confusingly. They say interstitial fluid is extracellular fluid, and they're right. But what there's extracellular fluid is the fluid outside the cell. Interstitial fluid is the fluid between the cells. They're the same thing. Interstitial fluid is the fluid around the cells. And it provides a place to reach out and get food when it's hungry, and a place to dump out trash later. I'm pausing on purpose for a second. I want you to absorb that. So this is important. This is extremely important. This is why we've been talking about cells. That means all of your cells, remember your whole body is made up of cells, every last bit of it, no exceptions. All your tissues are made up of cells. And those tissues are kind of floating in this wet stuff, this interstitial fluid. That's where they get their nutrients from. And that's where they go to the bathroom too later. And it's your circulatory system that comes and drops off plasma and blood and picks it back up again from this interstitial fluid. So let me give you an analogy that I think is more true about a way to think about your cells. And again, it's going to tie into massage. When people hear about the circulatory system, they think about, I say, oh, my heart pumps blood to my cells, right? And I say that, but that's not really true. That makes you think that you've got this big, beautiful heart here, right? 4-chambered heart, and it pumps blood down, and when it gets down to cells down here, it's got a little pipe that goes into those cells, just like you have pipes that go into your house. But that's not true at all. It doesn't have a pipe that goes to each cell. It has a lot of pipes really close to cells, but the pipes never go into a cell. The pipes go by the cells. So it's much truer to say that it's like a drip irrigation system for your garden. And your cells are in this soil, it's interstitial fluid, and they're picking up nutrients from the soil. So your interstitial fluid is fed by your circulatory system, and that's what they get, but they are literally like flowers floating in a hydroponic kind of setup. Actually, a hydroponic kind of setup where the roots are in this water. The water is the interstitial fluid. That's where they get their stuff from. And that soup is extremely important to your health. That soup is what you are balancing out all the time. My heart's pumping down plasma and blood and all that kind of stuff to that area and picking up waste products and trying to keep that soup healthy, because that soup is what my cells have to pick from to grab that interstitial fluid. By the way, once I pull the interstitial fluid into my little cell, what is that fluid called? Think about it. You know this. What do I call the interstitial fluid once it becomes inside my cell?
What, plasma?
Basically, yes, but what's the word we just learned? It has that word in it, basically.
Cytoplasm?
Cytoplasm, yes. Excellent. You just put it both together. By the way, cyto means cell. Yeah, no, cyto means cell. That's perfect. Cytoplasm. Yes, so cytoplasm is just the interstitial fluid inside the cell. Right? Like once food's inside your body, after a while we stop calling it food. We start to call it other things, right? It becomes the blood in your body, and it becomes the other stuff in your body, right? So this is important though, because massage can affect interstitial fluid health. Massage can affect interstitial fluid health. Massage can affect interstitial fluid health. which means you can affect how healthy somebody's flower beds are, which means you can affect how well their flowers grow. That's why we care about all this silliness. Oh gosh. We're not going to worry about this actually. Your book talks about embryonic tissue layers. That's when you're born, your little baby, and you become a person. I'm not going to spend time on that because I don't think we need to go through the whole gestation period and all that kind of stuff and what happens to you. I just think it's an awful lot of information to be thrown at you right now. I want you to focus on the building blocks of life. But the fact is that you have certain layers of cells that later turn into all the things that make you up. Because obviously when you're first conceived, it's just two little cells coming together and they divide. So the ectoderm is the outermost layer and it becomes your nervous system and your skin and all that stuff. And the mesoderm becomes the muscles and the connective tissue and all that kind of stuff. And the endoderm becomes all the epithelial tissue, all the inside stuff, which kind of makes sense if you think about it. But don't worry about it, please. Okay. Remember we said now we've got these basic building blocks of life, right? We took the elements, the atoms, we turned them into molecules, we created organelles, which are the organs for the cell. We made cells, you put a whole bunch of cells together. You've got tissue. We said, hey, these cells aren't just sitting like glued together, they've got water between them. It's interstitial fluid. And that's where they get their stuff to make their cytoplasm and live a happy life, just like you reach out and grab stuff out of your refrigerator to eat and make yourself a happy life. Your refrigerator's empty, you're in trouble, right? So we then said these tissues, where these cells come together, that there are four main types, and one of the main types was epithelial tissue, right? There was muscular, connective, nervous, and epithelial. Epithelial tissue. Epithelial tissue lines and covers the body structures. It provides protection and absorption, and believe it or not, it lets them slide over one another. Stuff in there has to wiggle around a little bit. When you're running around or getting massaged, stuff has to get moved around in there. And epithelial tissue lines all these openings inside my body on the insides and outsides of organs inside my body. It's all inside. We're not going to worry about this craziness. Not going to happen. So that's all I want you to know. Epithelial tissue lines, organs inside and out, all that good stuff. Connective tissue. Connective tissue is really important because it provides a framework for everything in your body. So remember I even said even your bones have this kind of connective tissue in them that then gets filled in with calcium and potassium and becomes concrete. But the connective tissue is there first. So it provides a framework that holds things together. You also have connective tissue though, like in your liver and your kidneys and everything like that. Otherwise, the liver and kidneys are so soft, they wouldn't hold their shape, they'd fall apart. So there's connective tissue in them too. Your muscles are actually very soft and very fragile, except there's connective tissue in them to give them structure and shape. Your connective tissue, by the way, also, even though it's not part of your defensive system, it can provide protection too. It can provide linings around really important things in your body. For example, your brain and your spinal cord have a lot of connective tissue around them to seal them in and help protect them from diseases. So oftentimes when you're sick, your brain and spinal cord are not sick. They are actually sealed off from that kind of stuff because it's so dangerous if something gets into your brain. And there are diseases like meningitis when stuff gets inside there and it's not good. But anyway, you're sealed off from much of that stuff, and it's actually very hard for stuff to get into, and the connective tissue actually acts as a shield around those kind of things. So it's protective in that way too. It's physically protective in that it holds stuff together, it gives it structure, but it also seals stuff off. It's also protective in that sense too. I'm thinking about how much of this to tell you. There are types of connective tissue, fibrous. We already actually kind of talked about fibrous connections that kind of hold your head together. Bones, cartilage, which we find often between bones, and liquid. Your blood is actually considered to be a connective tissue. Sorry guys, I'm hopping past some stuff here because we're going to get to it later.
Mr. Tufska, are you at the break point? There's people asking for a break.
Oh gosh, I didn't see that because I got so much into that. Thank you very much for speaking up. Let's take a break, everybody. It's a lot. Take a break. 5-minute break. Thank you, Miss Waite.
You're welcome.
Be back on my slideshow. Yeah. And then there are types of connective tissue. And one of the ones I want to talk about is cartilage. And I want to talk about cartilage because we find it in joints. And in massage, we're all about bones, joints, and muscles and fascia. Bones, joints, muscles, and fascia all day long. So this is kind of backstory for bones, muscles, joints, and fascia. There are 3 types of cartilage that I want you to think about. The last one, elastic, I don't want you to worry about very much. Elastic makes up things like my nose and ears. It gives me just a little bit of shape, and it's very bendable. I can actually put my nose all the way over here and my ear all the way here, and they will snap back, I hope. All right, so that one I'm not too concerned about. I am concerned about the other 2, hyaline and fibrocartilage, because they make up your joints. So hyaline cartilage is this beautiful white bluish cartilage, and it covers the ends. It covers the ends of your bones. So if we were to break a joint apart, over the inside of this and the outside of this here, we'd find hyaline cartilage. And it's this very smooth, bluish white cartilage that covers the articulating surfaces of bones. All that means, articulating, is the part that moves. It covers those ends. And it helps to protect them because you don't want to be rubbing bone on bone. Now, sometimes between these things, they've got hyaline cartilage over both ends, but sometimes, like in my knee, I've got hyaline cartilage in my knee on both the bones here coming together, but I've also got fibrocartilage in the middle. I've got a pad in the middle to give me even extra padding. Or I have fibrocartilage between my vertebrae, that we talked about down here. It's a pad. So hyaline cartilage covers the bones, and sometimes you have a pad even between those bones that's fibrocartilage. Definitely find fibrocartilage in your discs, between your discs and your knee. Those are high impact areas. But every area's got this kind of hyaline cartilage in there because it kind of helps stuff slide over itself smoothly. That's it. That's all I want to tell you. It's just important connective tissue, and we care all about joints. So now we've learned, by the way, we didn't learn this today, but we're putting all this together now. You're learning more and more about joints. You now know that you get a bone we now know there's this hyaline cartilage around the bone. There might be fibrocartilage between them as a pad, and we know there's this big membrane around the bones, the joints that we study, this big membrane made out of connective tissue that's called what kind of membrane? Somebody throw me a bone.
Is it the mucous membrane?
Very close, by the way. Close because it does. It secretes a liquid. But it starts with an S.
Serous membrane? Serous?
Synovial.
Synovial.
Synovial membrane. And it secretes synovial fluid. And that's what makes this a synovial joint. My knuckles, my wrists, my neck, everything. Pretty much your body is a synovial joint. Not everything, but the stuff that we care about. All this stuff that moves a lot is synovial joints. So I'm just kind of tying this back into all that. Cool, cool, cool. I'm going to hop past some stuff because I want to get you guys to your weekend, for one thing. Remember we talked about heart tissue? We talked about muscle tissue. So cells, a whole bunch of muscular cells put together make muscular tissue. And we said there are 3 types of muscular tissue. What's the one we're going to be studying the most of in this course? From the 3 listed there. What is the one most studied in this course?
Skeletal?
Skeletal. Absolutely skeletal. That's the stuff that moves you. It's the stuff that hooks to bones and moves you. It's the reason I can talk to you right now. I am using all sorts of skeletal muscles, and the reason I can walk closer to you right now while I'm doing it and gesture is all skeletal muscle. Now, I couldn't live without my cardiac muscle because it makes my heart beat, and believe it or not, I couldn't live without my smooth muscle because my smooth muscle lines all my blood vessels and all my digestive tract and all sorts of stuff. So it's very important too. But we won't be studying that as much because we're studying the stuff that makes you move, skeletal muscle. Nervous tissue. So we talked about epithelial tissue that lines the inside of the body, connective tissue that kind of binds everything together. We talked about certain types of connective tissue, hyaline that goes over the bone, fibrous that is the padding between the bones, right, in a synovial joint. We talked about muscular tissue that I use in my skeletal muscles and my cardiac muscle and my smooth muscle that's running through here. And then there's also nerve tissue, the last tissue type, nerve tissue. Now there's all sorts of types of nerve tissue, but this is the stuff that's located in your brain, your spinal cord, and your nerves. I lost my pen. All right. This is all nervous tissue. Your brain is actually a big bundle of nervous tissue. It goes down a really thick wire of nervous tissue. Off of that, it goes down your arms, wraps around your chest with these nerve plexes, goes down your legs. That's all nervous tissue. And that's how you get signals. If you touch something with your finger over here, it's got to come back to here, back to your spine, and up to your brain. If you stub your toe, it's got to come up through here, into your spine, up to your brain. It has to. In fact, if you get paralyzed and we break that connection, now you can feel your arms still, but you cannot feel your legs. They keep stopping right here. And you cannot tell your legs what to do. You send a signal down here and it runs out. It cannot get down to your legs. It's that simple. And that tragic too. Cool? Nervous tissue is your communication tissue with your entire body. Everything's got to get back to the spine, and the spine leads back to the head. The head interprets signals, and the head also sends out the orders and says, okay, we stubbed our toe. Let's now, run around the room holding our toe. Whatever you decide to do. Cool? All nervous tissue has the characteristics of excitability and conductivity. conductivity. That's fancy schmancy scientific talk for the fact is that it's electrical, it's conductive, just like a wire. You really can zap me with a little wire in my nerve here and make the muscle jump here. You really can, because my nerves actually conduct electricity. They're also excitable, which means you can hit them a little bit and they will send out their own electricity too. So some people with an inherited tremor, these are people like myself. I have an inherited family tremor. I don't know if it's not very much, but my nerves are excitable enough that they're sending out a tiny bit of a signal all the time. And that means they're kind of sending out their own little electricity and they're excitable. You want your nerves to be excitable to some extent. It's how they kind of send out a signal. They get a small signal and they send out another one. So they conduct electricity and they also send out a little bit of their own. Just excitable and conductive. They're wires. Really, that was their really difficult way of saying that your nervous tissue are wires. They really are wires. I mean, they're living, breathing wires and they're made out of tissue, but they conduct electricity and they send signals at an extremely fast rate, but just like telephone lines do. They really do. Okay. So we've talked about the 4 types of tissue. Yeah? Sometimes this tissue gets damaged. And when it gets damaged, it tends to go through 3 stages. One is inflammation. Can somebody tell me what inflammation is, very simply?
Isn't that like swelling?
Thank you. That's perfect for me. Yeah, it might have heat and other things like that, but swelling's good. So inflammation is essentially swelling, and your body is not dumb, it's smart. So if I hit my elbow, it swells up, and it's doing that for several reasons. It's doing that to help splint, to help immobilize my elbow so I stop moving it, to protect it. Also, if you think about it, what's all that swelling? It's more interstitial fluid. Oh, what? Yes! My body's like, this place needs to repair. I better send it more soup, more interstitial fluid. And it sends it with a whole lot of good soup, by the way, like white blood cells and all this cool stuff, and it swells it up and it's like, here, you get extra resources because you're hurting. It also gives it extra resources to take stuff out of it, right? But it's swelling with interstitial fluid, right? It's really important. That's the inflammation. It's probably hot right now, it's probably tender, and it's probably swollen. Now it can start regenerating. And that just means to heal. And then it can remodel. And remodel means to rebuild. That's it. So you go from kind of swelling, inflammation, all this kind of stuff, to starting to regenerate and kind of, work back together to remodeling. And the reason they put remodeling there as a separate step from regeneration is that when things are remodeling, they can be encouraged to remodel in one direction or another, right? There's a reason that when you get a hip replacement, they get you up and have you walking around. It's because they want you to remodel with your hip working this way. They want to make sure all the fibers and stuff remember what to do. They don't want them to grow thinking that you don't use that hip because you won't be able to move it. So movement is actually very important to remodeling. And when you massage somebody while they're healing too, you're helping to remodel the fibers. I already said that. Inflammation is a protective response. Inflammation is characterized. Miss Yana said swelling, and she's absolutely right. That's the big thing we think of. Heat, a loss of function, but remember that's good loss of function. Usually it's actually splinting itself, redness, and pain. And you can remember this was sharp. Swelling, heat, a loss of function, redness, and pain. Sharp. I love this picture. I really think it's very funny. It's in your book, and I wish I had time to let you look at it and laugh, but I don't because I have to move on. So I'm not going to worry about this. Factors that affect this healing. Factors that affect this healing. Do you see what I underlined there? Circulation of blood and lymph. Why? Because circulation of blood and lymph is how well new interstitial fluid gets in there for those cells to use up and repair themselves and heal, and bad stuff to get out and get carried away by the lymph. When there's a disaster, when there's a tornado, what do we try to do? We try to rush in supplies and carry out debris. That's how we help a city if we want to help them. We try to fly in supplies, get them in there, we try to get in extra supplies, and then we try to carry off the debris that was brought by the tornado. Your body's doing the same thing. Can anybody think of something that would help increase circulation of blood and lymph in the body? Anybody?
I got it. Massage.
Massage! Oh my God! Oh my God! You guys are learning to be increasers of circulation and lymph. You will actually make people heal quicker. Oh my God! It's amazing. The ability to heal. You can actually speed up the circulation of blood and lymph by about 4 times over the normal amount so that people will heal quicker. You're not healing them. Don't get too carried away. But you are giving their body what it needs to heal. And that's pretty amazing, right? So the person who's gone through the hurricane, I didn't fix stuff for them, but I gave them all the stuff they need to fix stuff. They're going to be pretty appreciative. The body's the same way. And they list this other stuff like nutrition and all that kind of stuff. Well, the nutrition doesn't get to them if they don't have circulation of blood and lymph. Blood and lymph is what brings the nutrition, right? It's all about circulation. Blood is life. Blood is life.
So it'd be kind of like an example of just giving somebody the tools.
Yes. Perfect. Perfect.
The healing
Yes.
process
Yeah.
in their life.
If you're running a fever and I say, well, what we've decided is to not give you any water or any food or any blankets, and we're just going to let you deal with that, you're going to die. But I don't come heal your fever, right? But I bring you over chicken noodle soup, give you lots of water, give you blankets. I give you the stuff you need to survive. Now, the body's already providing that stuff, but massage actually speeds that up and ensures it gets there. Yes. Okay. We've already talked about this stuff. Oh, gosh. I'm sorry to throw some of this stuff at you guys, but you're going to need to know it later. There are common membranes in your body, right? Common things like mucous membranes that you have in your throat and in your nose. They're actually gummy and gross, but they're not gross for a bad reason. They're gross for a good reason. They're sticky to catch bad stuff that comes into your throat. Serous membranes are epithelial type tissue. They're serous membranes. They wrap themselves around the organs of your body. That's why I said they're epithelial-like tissue. And you've got what are called parietal and visceral layers. And that just means you've got one around the organ and one around the outside the organ. And let me give you a great example of this. Your heart and lungs are wrapped with this type of stuff. Every time your heart beats, it's beat thousands of times during this lecture, it's rubbing against your lungs. Think about if you just sat here during this lecture and did this, and then you did this for 18 years, you'd bleed to death. You'd rub through your skin. Well, your heart has this serous stuff around it, and your lungs do too, so that they slide over each other. It's like 2 sacks sliding over each other, and there's a little bit of lubricant between them. That's what serous membranes are. And we care about them a little bit in massage because it allows your organs to slide over one another. And I think it's going to be on your test. That's why I'm bringing it up. Okay. We already talked about this. This chapter talks about anatomical position. This is what I meant. Like some of the stuff you've already heard now. It's starting to come together. You're going to start to see overlap. Anatomical position. My body's upright. My arms are at my sides, right? But my palms are facing out like this. And my feet are basically forward. We walk like this, and we should. That's fine. But this is anatomical position. This will matter later when we're talking about stuff. I'm not going to say more about it. You already know. Anatomical position. We've already talked about the sagittal plane, the frontal plane, the transverse plane, right? Sagittal, I don't like the way your book puts it here because it's very confusing. They say it bisects, it goes through your body from front to back, and it does. But sagittal divides your body from side to side. Sagittal starts with an S, Side starts with an S. Sagittal divides your body from side to side. Frontal, front to back. Transverse runs across me, top to bottom, right? Transverse starts with a T, top to bottom. Yeah? Nod. Nod with me. We've already gone over this. I don't mean that we're not going to review it again, but I also don't want to sit there and just, it's been a long lecture and I don't want you to have to hear it twice, right? But I'm sure you'll have questions on this. And I'm sure you'll know the answers. Beautiful picture. It's all chapter 18. You've got this to look at. One directional term that we have not talked about is ipsilateral and contralateral, and I'm mad we have to talk about them, but we do. I'm mad because we rarely use these terms. So ipsilateral means on the same side of the body, and contralateral means on opposite sides of the body. So if I'm moving contralaterally, I might be moving diagonal across the body. Ipsilaterally, I'd be moving on one side of the body. They're just terms to know. I think they'll be part of your vocabulary. I have heard them used before, but we use them very rarely. Contra means against. So contralateral means one side against the other, if that helps you remember that. Ipsilateral is the same side. Ipsilateral is the same side. We've already talked about medial, lateral, distal, superficial, deep, all this stuff you guys have already been hit with, right? We're going to do it again here, because remember what I did promise you, for better or for worse, is that you're going to hear stuff again, you're going to be tested on again, layered again, all this stuff. Directional stuff is super important, because we care about movements in the body. Yeah. It is very common when talking about the inside of the body to talk about the cavities of the body. What does the word dorsal mean? Anybody? Dorsal? Dorsal fin? Dorsal?
Back.
Back. Thank you.
Back.
Yep. Could be back of the hand, back of the back. Yes, back. You have a dorsal cavity that we don't think about, but the dorsal cavity is actually your brain and spinal cord. There is a hole down your vertebra. There is a hole down here. We don't think about this, but when we see the vertebra, we see this. What we don't realize is there's a hole that goes down there. That's your spinal cord. It's going down. That is a dorsal cavity. It's a hole running down there. There's a hole in your skull where your brain lives that's in the back here. That's a dorsal cavity, and your spine is a dorsal cavity. They're hollow, except they're filled with a brain and a spinal cord. And they're called the dorsal cavity. Then you have a ventral cavity, which is the front of your body. And it's divided into two sections. The thoracic section, what makes it the thoracic region? What makes this the thoracic region? How do I know I'm on the thoracic region right now? How do I know?
The ribs?
Thank you. Thank you so much, Ms. Torres. The ribs. The ribs are how I know I'm in the thoracic region. If there are ribs there, you're in the thoracic region. There are ribs associated with the thoracic region. Underneath here, so anything up in here is the thoracic cavity. I'm inside the thoracic cavity. What lives inside the thoracic cavity? Things like the lungs and the heart. Then you've got a diaphragm across here, and below that diaphragm is the abdominopelvic cavity. And the abdominopelvic is just like what it sounds. It's my abdominal region and my pelvic region, right? And that contains things like my tummy, my bladder, my reproductive stuff, all that is my abdominal pelvic region. These are just ways of dividing up the pockets in your body. Remember, cavities are just pockets or just openings. So you've got a front and a back. The dorsal side is the cranium and the spine, and the front side is the the front side is the ventral, I apologize, ventral, and there are two parts, the thoracic part and the abdominal pelvic. And maybe I should have said this before, sorry, but we're going to be going over this same chapter on Monday, so don't worry if it's not all sinking in right now. I should have said that right in the beginning. Yeah, because again, it's a lot, right? So Monday, we're still doing chapter 18. And we won't be doing probably more stuff Monday. We'll probably be going back over all this stuff, so don't stress. Cool? Because it's just a lot, right? But we can't teach you about stuff without teaching about cells and just basic stuff again, right? Cavities. Again, this is just good to know. Sometimes they like to divide the body, the abdominal pelvic area, up into quadrants. Doctors like doing this so they can talk about where there's certain problems, where a patient's getting pain. That's a very common thing. So my right upper quadrant, for example, would have my gallbladder. You know, it's just a way to talk about that area. Some people divide it up into 9 parts instead of 4, which is this next picture. And they actually give them all sorts of names. Do not memorize these names. You're going to get a question, I'm sure, on your homework on this. Don't memorize these names because you'll never use them again. Just answer the questions. I just want you to realize that some people divide it up into 9 spots to get more precise. In massage, it doesn't really matter. We don't use this terminology very often. It's just good you're aware of it. So somebody decides someday to say, let's talk about quadrants in the abdominal region, that you'll at least understand, like, oh, you're dividing the abdominal region up so we can talk about it. That's all you need to know. Trust me, I do not know all 9 of these regions. Right now, if you ask me to name all 9 of them, I could not do it. So, because I haven't had to know it for 25 years. Neither do you. Okay? But I want you aware of it. So if you get asked it on your homework, look it up and answer that one question. Don't stress about it. You already know about your axial skeleton and your appendicular skeletal system. We've already talked about this too. Your axial skeletal system is your skull and your thoracic region and your spine on down here. Your appendicular skeletal system is your appendages, your arms and your legs. It's that simple. Your arms and your legs is your appendicular skeletal system. So some of this stuff should be review in that sense, which is why I am flying through it. We have already gone over body regions too. This is what I meant. So you've actually already covered all this stuff, right? This is my cephalic region, remember that? My brachial region, remember that? Axillary region, remember that? My popliteal, the back of my knee. Every gal and fella has a patella, the front of my knee. We have done this already. Doesn't mean I know it doesn't mean you memorized it, but you've heard it, and if you get asked about it now, I bet you can figure it out. So you've already done some of this stuff, so it's not as overwhelming as it seems. That's it. Questions? Questions, questions, questions. The main purpose of the day was to kind of talk to you about cells and all that kind of stuff, but this chapter happens to include stuff that we've already covered because we're so amazing. And of course, one book talks about things differently than another book talks about things, right? So that's that. If you don't have any questions, I'll release another test to work on because you have a half hour left. And we'll see what kind of progress we make with that. Yeah? Questions, comments? No?